Hello and welcome to your first hands-on experience with wireless sensor networks. Today we are going to receive the data from the XBs in our Python program using the XB library. The sensor board is exactly the same that we use in the SenseEdge sensor. The other XB is directly connected to the computer in which we run the program. Let's take a look at what we are going to need to complete the lab. You will need one breadboard, hookup wire, one 20K ohm resistor, a photoresistor or light-dependent resistance, two breakout boards, two USB-A to Mini-B cables to configure the XBs, a computer, one XB configured as coordinator API. The API mode should be set to 1. One XB configured as router AT. Remember that in the XCTU configuration, the XBs should belong to the same PAN ID. The DH and DL of each XB should be the other's SH and SL. The router AT XB has to be configured to periodically take analog samples from the digital input-output 0 pin. We will use the same sensor board that we prepared for the SenseEdge sensor. All we need is a photoresistor and a resistor. We place both elements in series. This configuration is called a voltage divider. We connect the end of the voltage divider corresponding to the resistor to the 3.3 volts pin. Then we connect the endpoint of the voltage divider corresponding to the photoresistor to the ground pin. And finally, the middle point of our voltage divider is connected to the pin digital input-output 0 pin of the XB, which is configured as analog input pin. The voltage at digital input-output 0 is simply 3.3 volt times the resistance of the photoresistor, divided by the sum of the resistance of the photoresistor and the resistor. As the resistance of the photoresistor decreases when it receives light, the voltage at pin digital input-output 0 decreases. The coordinator XB needs to be connected to our computer. We will connect the second XB later on. Now it's time to write our small Python program. As usual, we import the required libraries. We initialize the serial port. Make sure that the coordinator XB is connected to the correct USB port. And then we define the function that will handle the data received from the XB. In this example, we simply print the received data on the screen. Then we initialize our ZigBee object indicating both the serial port and the function that we have just defined. After that, all we have to do is to sleep. Seriously, we jump into this loop that sleeps until the user presses OK. When the user presses OK, we abandon the loop stop, the ZigBee object and the port, and we are done. Let's start our program. Unplug our router XB to power it on. And now enjoy this flow of information in our screens. Now that we have our measures in the Python program, we can use all the power of Python to do crazy things with the data. Think about imaginative ideas to extend and improve this example. I'll leave a link to your work in the comments.